In this video, you're going to learn about Ohm's law. Ohm's law is current through an ideal conductor is proportional to the applied voltage, whereas your conductor is also known as a resistor. An ideal conductor is a material whose resistance does not change with temperature. For an ohmic device, remember this: voltage is equal to current times resistance. Okay? How are you going to get your current? Your current now would be equal to voltage all over resistance, and your resistance is equal to voltage all over current. Okay, so we have the units for your voltage, current, and resistance as volts, amperes, and ohms, respectively. Conventional current. The current in electrical circuits. Flow of current from positive terminal to the negative terminal. Remember that the flow of current is from positive to negative terminals. Okay, it has units of amperes and it is measured using ammeters. Voltage, it is the energy required to move a charge from one point to another. It has units of volts and is measured using voltmeters. Think of voltage as what pushes the electrons along in the circuit, and current as a group of electrons that are constantly trying to reach a state of equilibrium. Okay, we have your ohmic resistors. These are metals which obey Ohm's law linearly so long as their temperature is held constant. Their resistance value do not fluctuate with temperature. The resistance for each resistor is a constant. Most ohmic resistors will behave nonlinearly outside of a given range of temperature, pressure, and etc. So we have the voltage current relationship for linear resistors. Okay, as you can see here, your voltage now is the independent variable, the x-axis, while your current is the dependent variable. Okay, as your voltage increases, your current decreases. Voltage and current are linear when resistance is held constant. So we have the following. The total resistance of a circuit is dependent on the number of resistors in the circuit and their configuration. Okay. For series circuit, we have your total resistance would be equal to R G, or R is equal to summation of your resistors, while for the parallel circuit, we have the reciprocal relationship of your total resistor would be equal to the summation of reciprocal of the resistances or resistors. As you can see here, for Kirchoff's current law, current into junction would be equal to current leaving junction. I in is equal to I out. The amount of current that enters the junction is equivalent to the amount of current that leaves the junction. As you can see here in the diagram, your I in now would be equal to the summation of your I1 and I2. Okay? To determine now your I out, you have to equate it to your I in. Hence, the difference between your entering current to the exiting current would be equal to 0. Okay, sum of all voltage rises and voltage drops in a circuit when a circuit is in a closed loop would be equal to 0. So your voltages in would be equal to summation of voltages across each resistors, or V in would be equal to your amount of voltage here plus the amount of voltage here, and so on. Okay. Okay, so we have two types of circuits. The first one is your series circuit. For your series circuits, the current is held constant. This is because only one path for the current to take. But the voltages here or the total voltage would be equal to the summation of individual voltage. And if we're going to apply your Ohm's law, V would be equal to I times R, whereas your current here, again, for a series configuration would be equal to here, 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 to the total current supplied across the circuits. And then your resistances or resistors, okay, for the total resistors would be equal to the summation of your value of resistance here, here, and here, okay? Namely as R1 plus R2 plus R3. Series equivalent circuit, okay, as you can see here. On this diagram on the upper portion, you will see here a diagram of a raw circuit. If we're going to simplify the resistance, since this is in series, we're just going to add it. So the total resistance would be equal to R, as you can see here. So if we're going to apply now, or we get the individual voltage on this side as V1 and R1, so V1 now would be equal to the total current, multiply it with the value of resistance here, and so on. For individual voltages, I repeat, individual voltages is equal to the total current multiply with the respective individual value for their resistances. Okay. You can see here the summation of your resistances R would be equal to R1 plus R2 plus R3. The same goes with your total voltage. Your total voltage would be equal to V1 plus V2 plus V3. Okay. Then substituting now the individual formulas on how you're going to get the individual values for your voltages gives us this one. Okay. So if we further simplify it, it gives us this one, your Ohm's law for series equivalent circuits. Then we have your parallel circuits. Okay. For parallel circuits, your resistors are connected node to node. As you can see here, we have a separate node for your third resistor and a separate node for your second resistor here, as well as here for your first resistor. So why is it the voltage is held constant? There are three closed loops in a parallel circuit. Okay. Your V now would be equal to the same if we're going to apply your Ohm's law as current multiply it with the resistance. And then your total voltage here would be equal to the individual voltages. Okay. So take note. Okay. Take note of this. For the series circuit, your current total current would be equal to the individual current. And then for your parallel circuit, your constant here is your voltage. So your total voltage would be equal to the individual voltages. Okay. But the current would be now equal to summation of individual currents. To solve now your resistances, you're going to get the reciprocal for the total resistance. For the total resistance now, 1 all over R would be equal to 1 all over R1 plus 1 all over R2 plus 1 all over R3. Okay. So you can see here, if we're going to simplify the solution of this one, we have three resistors here. And then to get now the resistance of R2, 3, okay? Since your R3 here is parallel with R2, so we have to solve it separately. To get now your R2, 3, it would be equal to 1 all over 1 of R3 here plus 1 all over R2, okay? As you can see here. So if we're going to further simplify the total resistance here, this gives us this one, okay? And then if we're going to have simplified further here, we had get the value for your R23, okay? This is now parallel with your R1. How are we going to get the resistance across this one. So we have here your 1 all over R, which is the total resistance, would be equal to the reciprocal of your resistor 1 and reciprocal of whatever you got from your resistors R2 and 3. Okay? So this simplify us to further here. Okay? Instead of using 1 all over R, in this example, it has used 1 all over R, 1, 2, 3 to denote that you have already solved for the resistors of 1, 2, and 3. Okay? Remember that for a parallel configuration, your current would be equal to the summation of the individual currents. Okay. If we're going to solve now for the total voltage, your total voltage is equal to the what? Total current multiply it with the total resistance. Okay. Which gives us this one, the following relationships. We have this series circuit analysis for this first example. A 4-volt battery is placed in a series circuit with 2 resistors. What is the total current that will flow through the circuit? Okay, so we have this diagram. Although it is not stated on the problem what would be the values of the resistor, this is 2 ohm resistor. As you can see here, we are given with 2 ohms and a voltage of 4. Okay. How are you going to solve now for the total current? Remember that our relationship of voltage with respect to our Ohm's law would be equal to current multiply it with your R, or V is equal to IR. To solve now for the total currents, I now would be equal to V all over R. So if we're going to plug in the values for volts all over 2 ohms, this gives us 2 amperes. Okay. So we have your second example here. A 110-volt supplies a load with a resistance of 3 ohms, 5 ohms, and 7 ohms respectively. Find the current in the circuit. Okay, as you can see in the diagram, your 3 resistors are connected in a series. Okay, and then there is a battery supplying the whole system or whole circuit. So how are we going to determine now the current? Okay, so we are given with your total voltage as 110 volts, and then the following resistors as 357. So solving now for the total current, first we have to sum all the values for your 3 resistors. Okay, the sum would be 3 plus 5 plus 7 ohms gives us 12 ohms. Now, if we're going to plug in this on your Ohm's law, I now would be equal to the total voltage all over the total resistors. So this gives us 9.17 amperes. We have this parallel circuit analysis. A 220 volt is connected in parallel with the load. It has a resistance of 50 ohms and 100 or 10 ohms. Okay. Find the total current and the current one here and your second current here. Okay. If we're going to solve this one, we have this diagram. We are given with the following. We have your total voltage as 220 volts. Remember that your total voltage in parallel circuit is equal to the first voltage and second voltage, or the voltage that flows on your 5 ohm resistor and 10 ohm resistor. So your R1 would be equal to 5 ohms and your second resistor as 10 ohms. If we're going to solve now for the individual current, okay, I1 would be equal to total voltage all over R1. So 220 all over 5 gives us 44 amperes. For your second current, we have 220 all over the value here as 10 ohms gives us 220 amperes. If we're going to solve now for the total resistors, remember that total resistor would be equal to 1 all over RC is equal to 1 all over R1 plus 1 all over R2. If we're going to solve that, leaving RT on the um, left side of your equation, RT now would be equal to 1 all over 1 all over R1 plus 1 all over R2. If we're going to further simplify that mathematically, this gives us this formula as RT is equal to R1 multiply it with R2 all over the summation of two resistors as 5 times 10 all over 15 or 3 and 1/3 ohms. Okay. For the total current now, IT is equal to V all over RT or 220 all over 3.33 gives us 66 amperes. Okay. Find the total voltage and total resistance of the load if the total current is 15 amperes and it has a resistor R1 of 6 ohms and R2 of 2 ohms. So if we're going to base the diagram here, okay, we are given with this parallel circuit, your IT is equal to 15 and your first resistor as 6 ohms and your second resistor as 2 ohms. So we're going to determine your total voltage and total resistance. How we're going to do that? Okay, so we are given with the following to get now your total resistance, since this is only two parallel parallel resistors, okay, RT now is equal to R1, R2 all over R1 plus R2. So if we're going to plug in the values, this gives us 1.5 ohms for your total resistance. And then for the individual currents, I1, since we are not given yet with the total voltage, how are we going to solve that? Okay, VT now would be equal to your total current here as 15 amperes all over your total resistors as solved here. So 15 amperes times 1.5 ohms would be equal to 22.5 volts. So this is the value for your total voltage. Okay, for your individual current now, we're going to proceed. Your I1 is equal to total voltage all over your R1. So 22.5 all over 6 gives us 3 3/4 of your amperes. And for your second current, for resistor 2, okay, I2 is equal to V all over R2, or 22.5 all over 2 gives us 11 and 1/4 amperes. Okay, so we have this parallel series combination types of problems, which is um, commonly given by your instructors. Okay, in this example, we are given with this one. Your R3 is parallel with R2 and then R2, 3 is in series combination with R1 and R4. We are given with the total voltage as 60 volts. So we're going to determine now the following: your total resistance, your total current, your individual currents as I1, 2, 4, and individual voltages from points 1 to 4. Okay, we're going to determine that. We are given with this circuit. Okay, to determine now, the first step for this type of circuits, you have to simplify first this parallel configuration. Here we have your resistors 2 and 3. Okay, how are we going to get the resistance here? First, we have to use your formula for your resistors. Okay, for resistors connected in parallel circuits, okay, we have this one 1 all over the total resistance would be equal to 1 all over the resistance value on this two resistor 2 or second resistor and third resistor as 1 all over 8 ohms plus 1 all over 8 ohms. So how are you going to determine or simplify this one? If we're going to simplify this one, get the reciprocal of the whole equation, which leaves us R2 and 3 would be equal to 1 all over 1 all over 8 ohm plus 1 all over 8 ohm. If we're going to simplify this, this gives us 4 ohms. To determine now the total resistance for this current, okay, your R total would be equal to R1 plus your R23 as 4 ohms plus your R4. So if we're going to further substitute the values, this gives us 5 ohm plus 4 ohm plus 6 ohm, or a total of 15 ohms. Okay. For the total current, this is calculated as total voltage all over total resistance. Okay. So we have your total voltage here as 60 volts all over 15 ohms. Okay. So since we have simplified the value of your resistors here as 4 ohms, the whole connection now is connected in a series configuration. Okay. So since this is series configuration, your total current now would be equal to the current passing here, here, and here. Okay. So your total current is equal to this one as 4 amperes, which is the same with the resistors on 2 and 3. If we're going to further simplify this one, this gives us the following. Your voltage at this point would be equal to 20 volts. How are you going to get your 20 volts? You're going to use your Ohm's law. V would be equal to IR. Okay? So we have this one, your 4 amperes, multiply it with 5 ohms. Okay? Which leads us to 20 volts. For your resistor 2, we have I2 R2 as 2 amps multiplied with 8 ohms, which leaves us 16 volts. For your um, third resistor, okay, to get now the voltage there, be equal to this one, 2 amperes multiply it with 8 ohms, gives us 16 volts. And then for the fourth resistors, okay, to get now the voltage for the fourth resistor, I4 multiplied with your R4 as 4 amperes multiplied with 6 ohms, which leaves us with 24 volts. Okay, so to finalize our answer, these are the calculated values. Okay, we have the final example for your Ohm's law presentation. Find the equivalent resistance REQ for the following resistor combination in circuit. So we have this one. Your R8 and R10 is parallel with your R9. Okay. If we further simplify this one, first we have to sum both your R8 and R10. Since these are in series configuration, so R8, 10 would be equal to 12 ohms. Okay. If we're going to get now the um, RA here, okay, according to this diagram, the whole part here is simplified as RA. To solve now for the RA is equal to the resistor 9, multiply it with the sum of the series resistor of R8 and R10 all over the summation of the whole system. We have your R8 and R10, R9. So if we're going to substitute the values, 6 multiplied with 12 all over 18, this gives us 4 ohms. Okay. If we further simplify this one, since we have already determined your RA as 4 ohms, so since your RA and R7 are in series circuits, you're going to add this one. This gives us 12 ohms. And then since this one, the total here is in parallel with your R6. So the whole circuit here is called as RB. Your RB now would be equal to R6, multiply it with the sum of this one, RA plus R7 all over the total resistance over here in the RB. So if we're going to plug in the values, 6 multiply it with 12 all over 12 plus 6, which gives us 4 ohms. Okay. So since we are done simplifying the whole circuit, now for the next step, okay, since your RB is equal to 4 ohms, your RB is in resistant in series connection with 4 ohms. Okay. So this one, your RB and R5 is in parallel connection with your R4. Okay. Let's call this whole system as RC. So RC would be equal to R4, multiply it with the sum of RB and R5. Okay. All over the total sum of this one, which gives us 8 multiplied with 4 plus 4 all over 8 plus 8, thus simplifying the whole RC as 4 ohms. After simplifying your RC is in series connection with your third resistor, okay? And R3 and RC is in parallel connection with your R2. So the whole circuit is in parallel connection, and we're going to name this as RD. How are you going to get your RD? Now, your RD would be equal to R2 multiply it with RC plus R3 all over the summation of the 3 as 8 multiplied with 8 all over 8 plus 8, which gives us the value for your RD 4 ohms. Okay? After simplifying the whole equation, if we're going to determine now the total resistance, this gives us 4 plus 6 ohms since both are in series connection. This would be equal to your resistance equivalent for the whole circuit as 10 ohms. Okay. So for further questions, you may message me through my messenger account, or you may inbox me or drop a message on our LMS inbox. Thank you for listening and have a nice day.